Hello, my name is Kokshan Yang and I'm your instructor for this course in SQL, and we will focus with duckdb. So this is SQL with duckdb. Welcome to this course. We'll jump directly into the slides. So this first lecture is about turning data into valuable insight using SQL. And here we'll get some introduction to SQL and what it is and why we are using it in this course. So let's start with an example. We have an ice cream startup called Swedish Klassiker, and this is quite funny if you know Swedish. And it's using some Excel sheets to store data. So we have orders, they are stored in Excel sheet. We have customer data, they are stored in Excel sheets. We have inventory data, they are also stored in Excel sheets. So this is okay in the beginning, but the company grew. We got more people in our team. So then each Excel file is shared across the team. So we have one person there, another person there, another person, and another person. Everyone is using the same Excel sheets, and we're sharing the data inside. So we're updating it, and we put the Excel sheets in, we put it in SharePoint. Yes, we put it in SharePoint. So common problems that arose when we shared Excel sheets in this way. So we got data duplication because some people missed that another one has entered the same person in the customer, for example. And maybe it entered in with another type of name, so that the name may have changed a little bit, and then we have data duplication, which is not really good. So accidentally creating duplicates. So we're manually updating in several places. So we need to update in several places whenever we get new customers, whenever we get new orders, etc. The data becomes inconsistent. We'll come back to what that means later. We have another problem with relationship that is problematic. So it's hard to manage manually the links between customers and orders, for example, because we need to manually see that this order corresponds to this customer. And for example, if we have data duplication, then we don't know which customer is related to which orders. So that is more problematic. And the teams, they manually link the orders to the right customers. So it's a lot of manual work. This is quite tedious and hard. And when the data becomes larger and larger, we have performance issues in Excel. So it becomes much slower to work with the Excel files. And there's a lot of other problems as well that we won't go into right now. But to illustrate this, we have an example of inconsistent data due to manual input. So look at this. We have Alice Frost in ID 1. We have Alice F in ID 3. And we're not sure which one corresponds to the correct Alice. And then when we do this and we try to link it into other tables, then we have other issues, right? So the common question is this the same person? Well, we have the same address, we have the same phone number, but the email are different and the names are different, right? Somewhat different. So now which Alice is linked to what orders in the orders table? So in order to solve this, we use a relational database and SQL. We can handle many of these issues that arise. So we have defined relationships in SQL tables. So this ensures that we have data consistency. So what this means is that we have we will only have one unique data entry. Since we have defined how it's related to other tables. So we don't have duplication. And also in SQL, it's optimized for large values of data. in relational databases. So it's scalable and efficient to query the data. And also we will go into something called, so there's a difference between two different types of database systems. One is OLAP and one is OLTP. And we'll go into during the course the difference of them. So for example, OLAP, which duckdb is, it's really scalable and efficient for querying a lot of data. And OLTP, it's more when you're having a lot of entries, you have a lot of inserts, then it's optimized for that. So we can add some data constraints like data types and unique values. So this gives automatic validation, which will reduce the errors, and a lot of other important things in SQL and relational databases that will help us. So what is SQL? We check here. So SQL, it means structured query language. And in this, we can create, update, organize data in different tables. It's a standardized language. So it has been around for a very long time, since the 70s. However, there have been a lot of different dialects of SQL. So then, but it still implements the standard features, but some syntax are somewhat different for different dialects, and there's some different features for different dialects as well. And the dialect we're working with is duckdb in this course. And it's based on a relational model, which organizes the data into related tables. It links the data through unique identifiers, which is foreign keys and primary keys. And actually this we will go into in the next course, where we'll go into data modeling. So in this course, we won't really focus on unique identifiers and keys. So that will come in the next course, in the data modeling course, where we'll create different data models, we'll link the data from table to table, etc. Oh, sorry. And the core functionality of SQL is we have DDL, data definition language, which means we use this for we create tables, we create database objects, we can alter tables, alter views, we can drop tables, etc. So these are the data definition language. And then we have data manipulation language, which is inserting data, we update the data, we delete the data. So we manipulate the tables. And we have data query language, DQL, and this is for selecting. So we retrieve the data from the database, and we can filter on what we want to retrieve, what we want to query. And then we have something called DCL, data control language, and here we give permissions, so we can grant and revoke different types of permissions to give different types of roles, so that different people or different roles get various type of permissions, so that not everyone gets admin permission. However, DCL doesn't exist for duckdb, so we won't come into it in this course. This will be more into the next courses that we will have. So talking about duckdb, since I've already introduced it, so it's a modern, powerful database management system for analytics, and it's quite really modern actually. It's recently developed, and it has gained a lot of popularity in the field of data analytics and data engineering. So since this course is part of the data engineering program, my idea is that why not learn SQL using a really modern database management system from scratch. So then we picked duckdb. So it's OLAP. it's optimized for intensive analytical queries. So there's something called column-oriented database, which duckdb is. So it's really good for querying, very, very optimized for that, and doing several joins, etc. Super high performance. It works on your own machine. It can handle large data sets, even data sets that are larger than what your machine can handle. So it's embedded database, so you don't need a separate server like Postgres, like MS SQL, and MySQL, etc. Here you have a file-based, so the database is contained in a file. So there's no need for a separate server. And it integrates very well with other tools in the data science and ecosystem, such as Python, Pandas, and data frames. And you will notice this later on when we will connect with Python. It's really, really easy. Data analysis, it can run complex queries for analytics and reporting. So it's really useful for making, you can have it as a backend to make dashboards. So it works very well in data transformations, in different types of pipelines. So we call it ETL pipelines, and we'll come into that later on in your data engineering journey. So you have data transformations in an ETL pipeline to serve business intelligence and AI. So basically, the data comes through in the duckdb, and you do transformations there, and then it goes downstream to serve business intelligence and AI. So here we have a data engineering pipeline with an OLAP database as a data warehouse. So you have a different data sources. So it could be CSV files, it could be APIs, it could be other APIs, could be some kind of CRM system, etc. So these data, they go into a data warehouse, and the data warehouse, you do a lot of transformations, and then you serve the data to a dashboard. You serve the data to machine learning models. And here you extract the data. You start with extracting the data, so it's in data ingestion into the data warehouse. Inside the data warehouse, you do transformations, and then you do serving to the different to dashboard, to ML models. And duckdb, it could work as a lightweight data warehouse for small to medium-sized data. So you can use the duckdb as a data warehouse. Okay, so with this, I would like to thank you for listening, and see you in the next lecture.